Hi everyone. Today we're going to study optimization. In this video, we're going to see to maximize the area of rectangle. One common application of calculus is calculating the minimum or maximum value of a function. For example, companies often want to minimize production costs or maximize revenue. In manufacturing, it is often desirable to minimize the amount of material used to package a product with a certain volume. The basic idea of optimization is the same. We have a particular quantity that we are interested in maximizing or minimizing. However, we also have some auxiliary conditions that need to be satisfied. Here, we are interested in maximizing the area of a rectangular garden. Certainly, if we keep making the side lengths of the garden larger, the area will continue to become larger. Here now is the problem-solving strategy of optimization problems. We have 6 general steps. Step 1. Introduce all variables. If applicable, draw a figure and label all variables. Second, determine which quantity is to be maximized or minimized, and for what range of values of the other variables, if this can be determined at this time. Step 3. Write a formula for the quantity to be maximized or minimized in terms of the variables. This formula may involve more than one variable. Step 4. Write any equations relating the independent variables in the formula from step 3. Use these equations to write the quantity to be maximized or minimized as a function of one variable. Step 5. Identify the domain of consideration for the function in step 4, based on the physical problem to be solved. Step 6. Locate the maximum or minimum value of the function from step 4. This step typically involves looking for critical points and evaluating a function at endpoints. This is now our sample problem. A rectangular garden is to be constructed using a rock wall as one side of the garden and wire fencing for the other 3 sides. Given 100 feet of wire fencing, determine the dimensions that would create a garden of maximum area. What is the maximum area? For our solution, first, let us draw the problem and label it. Here is our drawing. On this side is the rock wall. Then we label this side to be X, and this side is also X, while the side here will be Y. Based on the problem, we want to get the dimensions of maximum area. So let us maximize the area of the rectangle. Our formula for area of rectangle is length times width. Considering the variables here, we write A equals x times y. We regard this now as equation 1. Next, we're going to write formula for constraints. In the problem, we're going to place wire fencing of 100 feet on three sides of rectangle. So we write here 2x plus y equals 100. So this equation is regarded as equation 2. Going back to equation 1, we can see that there are two variables on the right side. Our goal now is to make this formula of area in terms of one variable. So what we're going to do is to manipulate the equation 2 such that it becomes y equals 100 minus 2x. We isolated the y. And from here, we will substitute this y in terms of the variable x in the equation 1. So the area formula will be A equals x times y, but the y becomes 100 minus 2x. Simplifying the right side, we have now 100x minus 2x squared. We have now the right side of equation 1 to be in terms of x only. Now we are ready to take derivative. So the a here becomes a prime equals 100x is now 100 minus the derivative of 2x squared is 4x. From here, let us set a prime equals to 0 and let us solve for x. So it becomes like this. Solving for x, let us transpose negative 4x on the left side. It becomes positive 4x equals 100. We want the value of x. Let us divide this equation by 4. So the x now becomes 25. Now let us solve for the value of y using this formula. Let us substitute the value of x as 25 in here. So we have now y equals 100 minus 2 times 25. 2 times 25 is 50. So 100 minus 50 equals 50. So the value of x is 25 while the value of y is 50. We do not forget the unit of measurement, that is feet. These are the dimensions. Now, let us find the maximum area. Let us substitute the values of x and y on the formula 1. So we have a equals 25 times 50, and this is equal to 1250. The unit of measurement is square feet. This is the maximum area. These are now the final answers. I hope you learned something from this video. See you again next time.